Hello, we're on 9.06 geometry today, and we're talking about similar right triangles and the geometric mean. That's a fun one. All right, so first of all, to find your geometric mean, you're going to take, it's just a proportion. So the product of the means equals the product of the extremes. So think about if you were reading columns, right? You would read here first and then read down the column, and then you go to your next column and read to the end of that column. So the first and last places you would read are here. Think of those as your extremes, the beginning and the end. So these would be your extremes. And then in the middle are your means. Now, the means for the geometric mean is always going to be the same. Okay, so our mean proportional is a positive number x such that a over x equals x over b. So again, that x is your geometric mean. That's going to be the same. So if you were to solve this, then you'd have x squared equals a times b, or x equals the square root of ab. And this one, we're only going to take the principal square root, which just means the positive square root. Think your principal is very positive, only the principal square root. All right, so let's first just find some geometric means before we start doing it with our triangles. So number one, find the geometric mean of 12 and 4. Okay, so if those are my two numbers and I want to find the geometric mean of them, I'm going to take those two are going to become my extremes. And then my geometric mean are those middle numbers, and those have to be the same. So we set up our proportion, and then we're just going to cross multiply. So now we'll have x squared equals 48, and then solve for x. So we take the square root. Again, you only want the positive square root, and then we're going to put it in simplest radical form. So find the largest perfect square you can take from 48, which is 16 times 3. So x equals positive 4 rad 3. So 4 rad 3 is the geometric mean of 12 and 4. Okay, try another one. Find the geometric mean of 3 and 27. Pause the video, see if you can set that one up on your own. Whoops. Having a little trouble scrolling today. So here again, you should have 3 over x equals x over 27. Then cross multiply to get x squared equals 81. Take the square root. You only want the positive square root, and x equals 9. And we'll do one more. Find the geometric mean of 10 and 20. Pause the video, go ahead and find the geometric mean of 10 and 20. All right, so for that one, you should have gotten x equals 10 radical 2 in simplest radical form. Oh boy, I'm jumping a lot. Okay, so now let's talk about similar right triangles. So applying our geometric mean to similar right triangles. So first we're going to talk about our first theorem, which we're going to call PAP. And that says, and I'm going to write it out, but then we're going to break it down. So in a right triangle, the altitude is the geometric mean between the lengths of the segments of the hypotenuse. So this is our theorem. Oh, I went to the next page. So for this one, I'm going to just draw a nice picture here of a right triangle. So in a right triangle, there's my right triangle, the altitude, so let's drop our, we're going to draw an altitude here. So a line from the vertex perpendicular to that opposite side. The altitude is the geometric mean between the lengths of the segments of the hypotenuse. So what we mean by that is if we take this part of the segment and then we can take, this is the other part of the segment of the hypotenuse. So this whole thing is your hypotenuse and here is your altitude. So when you see problems like this, to recognize them, you're seeing that it's a right triangle with an altitude drop. So two right triangles inside of a big right triangle. And this is going to be our altitude rule. Which we call our PAP rule, P-A-A-P. So what that stands for is you're going to take part of the hypotenuse, P for part, over the altitude equals the altitude. Remember, those geometric means have to be the same. And we said the altitude is the geometric mean. So that has to be along the means over the other part of the hypotenuse. Maybe you also could call this PAO. So this is the other part, P-A-A-O-P, other part. So part over altitude equals altitude over part. So if we look at this triangle right here, if I call this triangle A, B, C, and this point D, my proportion here would be part of my hypotenuse, which is AD, over the altitude, which is CD, equals the same altitude, CD, over the other part, which would be your yellow part, which is DB. So that's how you would set up your altitude rule. So your PAP rule. So again, things you want to be thinking about are, do I see a big right triangle with two right triangles inside of it? And to use this rule, you want to either be given the altitude or looking for the altitude. Okay, so for all of these, you're going to find X. So here's your right triangle with an altitude drawn. So you've got two right triangles inside of a big right triangle. And we want to solve for X. So again, to recognize when you want to use this rule, it's either you're given the altitude or you're looking for the altitude. So I have a 4, so I know the length of my altitude. So that tells me that I want to use the PAP rule. So I'm going to take part of my hypotenuse. When I say part, I mean from one vertex of the triangle to the point where the altitude hits the hypotenuse. So this is one part, and this is the other part, so the other vertex. All right, so part of our hypotenuse is 3x minus 22 over our altitude, which is 4, equals that same altitude over the other part. Almost think of it like a semicircle here. It bounces up to the 4 and then back down. So 3x minus 22 over 4 equals 4 over x. And now we would solve it. So now we're just going to cross multiply. And so we have x times 3x minus 22 equals 4 times 4, which is 16. So pause the video and try to solve this. You are going to need to factor here and make sure your answers make sense in the end. All right, so you should have distributed here 3x squared minus 22x. Also want to get that equal to 0, so you should have subtracted over your 16. Since there's a 3 in the front, there's no GCF, I'm going to use P's and C's. So my P here is going to be negative 48. My center term is negative 22. So I'll do 3x squared blank x minus 16 equals 0. I need two numbers that have a product of negative 48 and combine to negative 22. If you're not sure what those are, feel free to go to your calculator into your y1 and do negative 48 divided by x to list the factors and look for 2 that combine to negative 22. And that should be negative 24 and positive 2. So I'm going to put those on the two blanks. Remember, we don't put the P and the C on the blanks. We put the numbers that have that product and add to the C. All right, now we factor out our GCF. So 3x, leaving us with x minus 8. Second set, we're going to factor out a positive 2 because the first number in the parentheses is 2, leaving us with x minus 8. And then we can regroup. So x minus 8 is written twice, so we're going to factor that out, write that once. Left with 3x plus 2 equals 0. Since it's equal to 0, we can set each of our factors equal to 0 and solve. So you should have gotten negative 2/3. Make sure you show setting it equal to 0 and 8. So now you go back to your picture and say, would both of these make sense? Well, in our picture, x is the length of this yellow segment, and we can't have any segments have a negative length. So we're going to reject the negative 2/3. The rest would all work if we have x equal to 8. So our final answer is x equals 8. Okay, let's do another one. So here's a right triangle with an altitude drop creating two right triangles inside of a right triangle. So to decide which rule, there's going to be two rules, by the way. This is the first one. To do this one, we see we're looking for the altitude. We called it x here. So to find x, we're going to use our altitude rule, which is p over a equals a over p, or your path. So part of my hypotenuse, it's always the hypotenuse of that biggest triangle that you see, is 16 over my altitude, which is x, equals x over 6. And then you're going to solve that, so we cross multiply, and then put that into simplest radical form. And again, you would not keep your negative here because x is the length of a segment, and we're finding the geometric mean, which means we're taking the positive value. And the largest perfect square, if you don't know, you can always type 96 divided by x into your y equals, look for a perfect square, see a 16. So we get 4 rad 6 for our value of x. Okay, so next up, we're going to talk, I'm going to go to this page. We're going to talk about the next theorem. Like I said, there's two theorems. So this one is the HLLP theorem, or help, however you want to say it. So I'll write out the theorem again like we did before, and then we'll see what it actually means. So the length of each leg of the original right triangle is the geometric mean. That's why we started with geometric mean. And all of these ratios also come from just having similar right triangles. Really, these are just shortcuts to set up the proportions of our right triangles. Because once you have these triangles, those three triangles are all actually similar to each other, of the length of the hypotenuse and the segment of the hypotenuse that's closest to that leg that you're looking at. So let's draw our right triangle again. So again, what I was saying just now is that when you have these three right triangles, so 1, 2, and the big one, 3, those three triangles will all be similar to each other. So all of their corresponding sides are proportional, but it's confusing because they're kind of flipped here and rotated around. So it's not as easy as it normally is to set up a proportion. So that's why we have these little shortcuts to help us, that PAP and help. So here we're going to use HLLP. So this is if you're not given the altitude and not looking for the altitude, we use this. So this stands for, H stands for the hypotenuse over a leg, and these are the hypotenuse of the entire big triangle, leg of the entire big triangle, equals leg over the part of the hypotenuse closest to the leg. So HLLP. So on this triangle here, let's again call it triangle ABC and D. If I wanted to set up the proportion for this one, I would take one of the legs. So let's start with AC. So AC over, don't start with AC. Take that back. We want to start with the whole hypotenuse. So the whole hypotenuse is AB over the leg we're talking about, which is AC, equals that leg repeated, same value here. Remember, these are your means, over the part closest. So is the part closest to this AD, or is it the other part of the hypotenuse, DB? Which one's closer to the leg of AC? And hopefully you're saying that yellow one is, so that would be AD over here. Or if you wanted to use this leg, if that's maybe the leg you were looking for, you would do the whole hypotenuse of the big triangle, which is that should be a straight line, over the leg, which is CB, equals that same leg over the part closest to that, which in this case would be the blue side. So the blue is closer to that squiggle line. And that's how we would set up our proportion for the leg rule, or the HLLP rule. Okay, so two theorems, the PAP rule, or PAP, and the HELP rule. So let's look at a couple examples of these, and then we're going to put them all together so you can see how to decide which rule to use. So we've got our right triangle. I want you to find X. So this is X. I'm going to give you this as A, D, B, C. This is 6, and AB equals 18. Find X. Okay, so for this one, notice we're not looking for the altitude. We're not given the altitude, but we are given one of the legs of that big right triangle. We also know that AB is 18. So that tells me that I'm going to use the HLLP rule. So I'm going to take my entire hypotenuse, which is 18, over the leg. So it doesn't matter which leg you use, AC or CB. You want to use the one that you're given information on. So whether you're looking for that leg or you're given that leg. So we're given this one that's 6, so we're going to use that one. And then we're going to do the part closest. So the part of the whole hypotenuse that's closest to the 6, which would be this part right here, which is actually just your X. If I wanted to use the other part, I would have to call that one 18 minus X for that, since X is already labeled. And now you're going to cross multiply and solve. So we have 18X equals 36 and X equals 2. All right, let's try another one. Number 4. So here you're given this is 7, this side part is 13, and this is X. So see if you can set up a proportion and solve this one. All right, so for this one now, again, not given the altitude, not looking for it. So I'm thinking HLLP, and that means I need the entire hypotenuse of the big triangle. So to do that, I'm going to add 7 and 13 to get 20. So now I take 20 over the leg. Now I'm looking for this leg, so that's why I want to use this one, equals that same leg over the part closest. So which part of the hypotenuse is closest to X? And that would be the 13. And then we cross multiply and solve. So we get x squared equals 260. Put that into simplest radical form. Again, reject that negative. Largest perfect square here we can take is 4. So you should have gotten 2 radical 65 for your answer. All right, so now I want you to decide between the two rules. So decide which rule. So you're going to use PAP if the altitude is labeled. So if is given or you're looking for it. Use PAP. If not, so if you don't have the altitude, use help. Okay, so that's how you're going to decide. So yes, this side is given the altitude or looking for it. This one is no altitude, not looking for it, not given it. So I'm going to put up a question, and I want you to decide which rule we should use to solve. So this is 2 rad 6, this is x, and this is x minus 2. So ask yourself, are we given the altitude? Yes, we know the altitude is 2 rad 6. So yes, we're given the altitude, which means we want to use PAP, all the A's in it. If you have the altitude, you want to use PAP with the A's. So to do that, we actually pause your video here and set up your proportion and then solve. All right, so part of your altitude would be x over the altitude is 2 rad 6 equals 2 rad 6. Again, the mean should always be the same over x minus 2. Be really careful about these radicals when you are multiplying them. So 2 rad 6 times 2 rad 6, you might want to put that into your calculator. Or if you're doing it out in your head, make sure you multiply the 2's together to get your 4, and your rad 6 times rad 6 would give you just 6, or rad 36, which is 6. So we'd have 4 times 6 gives us 24. In your calculator, be careful typing that in. And then here I'm going to distribute. I have an x squared and an x, so now I want to set that equal to 0. I want to keep x squared positive, so I'm going to bring the 24 over to get it equal to 0. And since it's a 1 in the front, I'm going to go straight to guess and check as opposed to P's and C's. What multiplies to negative 24 and adds to negative 2? Be negative 6, positive 4. Draw your line. Set each equal to 0. And double check both would work. Since x is the length of a side, or negative 4 minus 2, that would give me a negative. 6 minus 2 is okay, and 6 is okay. So final answer would be x equals 6. Okay, let's try another one. This one says SR is 1 more than PS, and I'll give you the picture in just a minute. PQ is 2 more than PS. Find PS. So this is Q, R, S, and P. So pause your video and try this one out. So label it and then set up your proportion and then solve for X and then solve for PS, which is, okay, so SR is over here is 1 more than PS. So let's call PS X. I mean, we're looking for that anyway. So now SR would be X plus 1. PQ, which is over here, that one is 2 more than PS, so let's call that X plus 2. So looking at this picture, hopefully you notice there's no altitude given and we're not looking for it. So you should be thinking HLLP. So we're going to take our entire hypotenuse for that one. So x plus 1 would give us 2x plus 1. X plus x is 2x. Over our leg, which is x plus 2, equals that same leg over the part closest to it on the hypotenuse. So we're looking at, is it either x or x plus 1? Which one's closer to that yellow leg? And that would be your x. All right, and then you should cross multiply. So you have x times 2x plus 1 equals x plus 2 times x plus 2. And now a lot of the distributing, factoring, all that fun stuff. So here we have 2x squared plus x. And then you should have FOILed this one out. If you haven't, pause the video and do that now to get x squared plus 4x plus 4. I have x squareds and x, so I want to get this equal to 0. I also want to keep my x squareds positive, so I'm going to subtract all of this over to the left-hand side, leaving me with x squared minus 3x minus 4 equals 0. I have an x squared and an x, so I want to factor that now that I got it equal to 0. There's a 1 in front of the x squared, or no number, so I am going to go straight to guess and check. Two numbers that multiply to -4 and add to -3. And then set each factor equal to 0. Solve, and of course, double check in your problem that both would make sense. -1 would not work because that's the length of a side, but 4 would work for all of them. So that tells me that PS, which is x, must equal 4. Okay. Find x. Go ahead, pause your video, decide which rule, and solve for all possible values of x. All right, so for this one thing I just want to point out, you don't have your altitude, so you should be using HLLP. So for your whole hypotenuse, you want to add those together to get 5 plus x, and then set up your proportion from there. You should have had to reject the -9. Your final answer would be just x equals 4. And here's another one for you to try. So again, find x. So this is A, B, C. AB equals 50, DB is 40, and CB is x. Pause your video, decide which rule, and solve for x. All right, so here you were given you're looking for the altitude, so you should be using your path rule. And we knew AB was 50, so now you can subtract 40 from 50 to find your 10 here, and then set up that proportion. And that one should have given you x equals 20, and I should see the proportion on your paper. All right, next one. So this one I want you to find A and B. So this is A, this is B, this whole hypotenuse is 50, this leg is 14, and this is 48. All right, so go ahead, pause your video, and solve for A and B. All right, so for this one, no altitude, so I'm thinking HLLP. So here I would take my whole hypotenuse 50, and you can decide which one you want to find first. So if you did 50 over 14 equals 14 over A, that'll find A for you. And that should come out to 3.92. Now to find B, you have to do another proportion. So that one, you're going to use the other leg because B is closer to that leg. So you would do your 50 over 48 equals 48 over B. And B would equal 46.08. So you could do it as your 50 over 48 equals 48 over B, or you could also have taken 50 and subtract your 3.92, which would give you your 46.08 as well, which is a little bit faster. All right. Number 10. Find X, Y, and Z. So right triangle with two right triangles inside. That's the picture you're looking for always. 7, 9, that's Y, that's X, and that's Z. Pause your video and see if you can find those three variables. All right, so first of all, you might say, oh, well, I'm looking for this altitude right here. So if I'm looking for the altitude, I might be thinking half. So I have both parts of my hypotenuse, so I could set up half there. So 9 over y equals y over 7. Cross multiply, solve there. You should have gotten y equals 3 rad 7. Now we still need to find x and z. So those are your legs. So since you're looking for the leg on those, let's look at x first. So if I'm looking for x right here, I want to use HLLP. So my whole hypotenuse here is 16. So I could do 16 over x equals my x over 7. And then for z, you're going to again use HLLP to take your 16 over z equals z over 9. X should be 4 rad 7, and z should be 12. Okay, so there we have to do 3 different proportions. We're using HAP first, and then HLLP for the other 2. All right, and the last one, number 11, in right triangle ABC, segment CD is the altitude to hypotenuse segment AB. The segments of the hypotenuse AB are in a ratio of 1 to 4. The altitude is 6. Find the 2 segments of the hypotenuse. I'm abbreviating in there too. Okay, so this one, I'm not giving you a picture, just all this information. I want you guys to pause the video, draw your picture, and then see if you can set it up and solve. All right, so we should have triangle ABC. We know it's a right triangle, and we know that CD is the altitude drop to hypotenuse AB. So we know CD is the altitude, and the hypotenuse is AB. So I know the hypotenuse is AB, which means this must be C, and the altitude is CD, so this point must be D. The segments of the hypotenuse are in a ratio of 1 to 4. Remember, whenever you see these ratios, you're adding an x on. So we want to have one of them is going to be 1x, and the other is going to be 4x. The altitude, which is here, is 6. Find the 2 segments of the hypotenuse, so the x and the 4x. All right, so here, pause the video if you just couldn't get the picture, and now try to set it up. All right, so here you're given the altitude, and so you're using PAP, so x over 6 equals 6 over 4x. Should have cross multiply. Make sure when you cross multiply here, you get 4x squared equals 36, and now you need to isolate that x squared, so divide both sides by 4. And then take your square root, and of course rejecting your negative. So we get x equals 3. It asks us to find the 2 segments, so x would equal 3 here, and 3 times 4 would give us 12. So AD in this case is 3, and DB is 12. So 3 over 12 are reduced to a ratio of 1 to 4. All right, and that is it for today. I hope you guys have a great day, and I will see you soon. And pie out.